So it's been 3 days, there was no upload due to some unforeseen circumstance. So yeah, but we're back. Today, on today's video, I think we plan on focusing more on the application architecture and setting up all the repository needed. I think we can go ahead and do that. And yep. So okay, so that's fine. Anyway, so moving on, right? Let's just quickly do a quick breakdown of how of the of what stacks we're going to be using and which is which, what language, and the rest. Okay, so oh jeez. So I think to break this down, right? Let's keep it simple. So we have two parts of this whole platform. We have the front end, right? We have the front end, and we have the back end, right? And we have the back end. We have the back end. So those are the two things. Those are the two ends, right? So now for the front end, I am suggesting we use React Native for mobile and maybe React JS for web application. We would focus more on React. Anything React is fine. It's fine. All right. So we would let's just duplicate this. So yeah, we are going to just keep it simple. So yeah, let's say React JS or React Native, right? So that is for the front end. We are not going to focus on the front end for today. We would focus more on the back end side of things, and I think that would give us a good head start. So for the back end, we have so many options. Since we are going to be dealing with a real-time tracking of all these orders and the table, the catalogs, yeah, so I think we want to use some kind of real-time messaging technique. So a very good option is Firebase. Another very good option is Pusher. However, we also have another option which is Socket.io or WebSockets, depending on which one we go for. I particularly would vote for Socket.io, basically because it's built on sockets. It's built on WebSockets. So let's see, Socket.io. So I think we would use Socket.io. Yeah, let's go to the documentation. So how does Socket.io work? I think anybody can go ahead and look at this documentation. Basically, you have your client, you have your server, and there is a bidirectional. Okay, that's it. Yeah, there's a bidirectional event-based communication between the client and the server, meaning both can talk to each other, simultaneously in real time, and it also, low latency. So yes, this is a very good one we can start with. Of course, we can always scale up. We can decide to change this implementation as time goes on, but I think this is a good start. And they have more support, from the look of things, they have more support with JavaScript, so we are going to use Node.js. However, so this is how I think we will go about it. So for the backend, we would for ordering and anything that has to do with real-time, events, so we would use Node.js. Why for business logic related stuff we would use Spring. We could use Golang. I mean, please, before we start, we can always suggest in the comment section. If you want Spring, if you want Golang, if you want even Node, we can always use something. So, but I currently am voting for Spring Boot, and it is very, very subjected to changes. So yeah, whatever the vote is, we can always go with that. So yeah, so this is it. This is it. So I think we then need to further break down the Node.js part, right? So a quick throwback, right, is let's go back to this, right? Let's go back to this. So what we are looking at is a multi-regional platform. So this is more like a platform as a service. So where we should be able to deploy this platform for each region, or deploy it for just in one place and then make it, work on based on multiple region. So this is what I mean. We need to be able to onboard Lounge from US, the UK, whatever region it is. We need to be able to onboard platform to onboard Lounge from anywhere in the world. And having said that, it will be very ridiculous if order they are coming from a customer in the US to a lounge, of course, in the US. It will be very ridiculous if that order goes through a channel where there is another region listening to it. For instance, let's say there is a lounge in the Europe region, but then they could also listen to that particular order. It would make no sense. I think a diagram would help. So this is what I'm trying to say. Let's say this is customer. This is a customer X places an order to a lounge. So let's just make the lounge. This is lounge A, right? So this customer places an order to lounge A. Dude, come on. To lounge A, right? Okay. So let's say this customer places an order XY to lounge A. Now, we want to make sure that our platform, being multi-region, so what that means is if let's make this bigger. I'm gonna make this very big. Oh jeez. Okay, I'm just gonna send this to the back. Right. Then we're gonna make these guys smaller. Right. We're gonna move this guy up. Yeah. So let's say there's lounge A, lounge B. Now we are as well going to just regionalize it. So the best way to look at this is to let's just draw a smaller box. So let's call this why can't I get it? Okay, cool. Let's just say US. Let's say the region. This is a region in US. Okay, this is a US region. And then let's say we have another region called the UK, just for instance, right? Now, this customer is from this region. So this is what we're gonna do. I suck at this, man. If I can do this. Alright, so let's just say this customer is from this region, which means this lounge is also from this region. So this lounge B, let's say it's from this region. And then we have customer B. Places order to this lounge. Let's call it customer Y. And then this customer is also from this region. So this is exactly what we want the platform to do. So let's say this is the platform, right? This is the platform. So this is exactly what we want the platform to do, meaning that whatever we build, whatever we build, a customer from region in the US placing an order, their order should never go through this region. Now, this can get really complicated very quick, but we would simplify it. So what we mean by that is, however we are setting up our socket connection or our socket server, we want to make sure that it's multi-region, meaning that lounges in the US, their orders doesn't go through a channel that is exposed to lounges in the UK. So it is as simple as that. So I think a more practical breakdown would make more sense. So now, just keep that at the back of your mind. Now, to proceed, let's simply create a socket. Let's say this is okay, so this is Node.js. Let me think through this for a minute. We have our Node.js application. Alright, so let's just simulate our socket connection. So this is what I want to do. So we're going to say in our socket connection, right? What's the best thing to use? Let's just go ahead and use this. Yeah, in our socket connection. Okay, that's fine. Socket. So in our socket IO server, so this is what we're gonna do. We want there to be, okay, first thing first, we talked about keeping things simple. So it is worth mentioning that we are not going to out of the box support multi-region for now. So we are just going to focus more on one region. However, I just mentioned this to make sure that whatever we are doing, we have it in mind that this platform would eventually have to support multiple regions, and that is inevitable, right? But yeah, we are just going to focus more on one region for now to simplify things so that we don't get caught up in too much complexity. So, having said that, we also need to keep in mind that regardless of what we are doing, we probably want to have multiple instances of the socket server running. So for instance, we are going to have this orchestrated, right? Meaning we would have something like maybe a Kubernetes cluster that would literally be running and be spinning up nodes, so that if for any reason any of this the application crash, it quickly spins up another node that is another application, another instance of this application, and then direct traffic to it. Also, in a situation where there are too many traffic it's basically just spin up multiple nodes and distribute the traffic across the nodes. So now moving on, 1 minute, pause. All right, so moving on. Okay, where are we? Yeah, the socket connection. So the way we want the socket connection to work, like I said, we want it to have multiple instances of the socket um, connection running, right? I mean, we want to make sure in a situation where multiple socket connection is running, we want to be able to um, manage um, events across all of those instances. So, and the reason is because if I remember vividly, sockets IO only support, I think, is it single? Let's see. Let's see. Mm. I can't remember vividly what the issue was, but I know there was an issue with socket IO the last time I worked with it, and you you have to make sure you manage the multiple instances of the socket IO that are created, else I don't think it's multiple state aware or something thereabout. Anyways, moving on. So this is what we want to do. So let's say we have multiple of this Node.js application running, like multiple instances of this Node.js application running. So we would have something like this. Let's say instance A, and then let's say we have instance B, right? So these two would most likely be running as individuals. So I think what we can then do is to use Redis. Let's see. I think sockets. You have a Redis adapter to manage. I think we can use this either this or the other one. So okay, a single stream is used for all namespace. Nice. This adapter is to forward packet between socket IO servers. Okay, yeah, this is exactly what I'm trying to say. So in a situation where we have multiple socket server running, we need to be able to forward packets between those socket IO servers so that none of them are missing the right message. So in a situation where for a particular region multiple socket IO server is running, we probably want to forward the message to those two servers and let the client facing application handle and filter out duplicates. So yeah, okay. I mean, we could also filter out duplicate ourselves. It's all about what we want to do. So moving on, we probably want to have Redis handling that for us. So we are going to do something like, let's just keep it something like, let me see, something like Redis. Yeah. So let's just put something here. Yeah, so it should be somewhere here. So I think this is how it would be. So yep, you can imagine it this way. Now this might not be totally correct, but we get the idea. All right, yeah, something like this. So Redis basically just handles keeps the instances, keeps the record of those instances, and helps us distribute or forward packets to those instances. So in a situation where this instance goes off and maybe comes back on for any reason, it should be able to go back to where it was. That is, let's say 10 other broadcasts have happened after this guy got turned off. We are going to try and write it in a way that it should know where it stops receiving broadcasts, and whenever it starts up again, it's return back to where it stops and picks up those missing broadcasts and process them accordingly as well if need be. So not to bore us too much on that aspect, so let's look at how this connects to this. So I think the best way to look at it is, so there is going to be a channel. Let's make it something like this. No. Let's just say there's a channel. Now this channel is going to be dynamic, right? So since we are focusing on just a single region for now, let's keep it very, very simple. So let's say we create a channel and we call it US, or let's just say, because we want to keep region in mind, so we just say region US underscore the lounge. You could even have states underscore lounge, because you could have multiple lounge of same owner, or we could have the same lounge in different states. So yeah, we probably want to keep that in mind. And so we probably want to create this kind of channel, right? So this is how we want that channel to look like. So it should be dynamic, right? It should be dynamic. So now we can have states, then the lounge ID, lounge UUID or something thereabouts, a unique ID. Now it's fine. Let us think about this too much. So the same thing applies to this anyway, whatever you want to see it as. Okay, so now we have our channel created. The next thing is for our front end. So we're just going to quickly say we have our React application. So I'm just going to say something there. Let's say something like this. React JS or React Native application. And what this would do is basically just subscribe to this channel. So it will just subscribe to this channel basically, right? And that should, it can be React Native or JS. So basically it subscribes to this channel, right? And how does that happen? Before it can subscribe, one thing has to happen before then, or perhaps two things. So in the React Native application, the first thing it has to do is to call the Spring Boot application, which basically helps fetch and return the list of lounge, right? So here we are going to have the list of lounge. Let's see. This guy is gonna come. Just get rid of this. So list of lounge. So this is a list of our lounge, right? So I think the other day we used something like Arizona lounge, just a sample. So basically, let's assume that our user or the customer, you know, fetches the list of lounge and then click on any of them. So the next thing that happens is this, right? It's subscribed to that particular lounge, and after it does that, it then go ahead to load the catalog, right? Or yeah, catalog actually. Or let's just call it list of items. Or let's just call it list of goods. Let's just put it that way. So now in this case it could be let's just call it chicken burger, right? And basically what happens is when they pick any of these, they then publish. So let's see, they publish back to this channel. So let's see, pops up. So in this case, let's go back here. Let's just do this. I know I suck at this. So yeah, it publishes the no, sorry, 1 minute. Does it publish or does it send to it could publish, but will that really make sense? Yeah, why not? Yeah, so it publishes to the channel, and then the channel basically just picks it up. So yeah, that is that about that. So the customer comes, they check for they find the list of lounge, they pick on their lounge, they go ahead to immediately you select your lounge, we get to load and subscribe you to that particular channel, which is that lounge channel, and then we go ahead and show you the list of their basically actionable things that you can do with the lounge. And from there you can go ahead and select your items, click on purchase or click on order, and basically what we just use to publish your order to that particular channel. So what happens is your order comes back to to that channel, and from our Node.js application we basically just push that particular item to Spring Boot, and also at the same time the okay, now this is the client facing side. Now let's quickly look at how this interacts with this is the customer facing side. So let's look at how this interacts with how this comes and join with the lounge side, which is the lounge dashboard. Okay, cool. So what would happen is, here we're just going to, actually we don't need to go too far. So this is going to be for both customer and it's going to be for both customer, and lounge. So this will be for both customer and lounge. You can just imagine it to be something like that. Yeah. So what this means is, the same way the lounge is going to subscribe to its channel, of course, to a channel. That is, of course, after they get onboarded. So they are going to subscribe to a channel, of course, when they come online. The same way they subscribe, the same way their customer going to subscribe to their channel and push orders to them. So yeah, I think we are good. We don't need to create anything new. Yeah. So basically what happens is, when a customer pushes an order, the lounge already subscribed to it, they get to see the order and they can go ahead to, of course, the way we would write it is to verify the order from Spring Boot, if need be, if there is any business logic that needs to happen, around the order, if anything at all. So I think that's pretty much it, and I really just hope it's not too complicated yet. So yeah, not really so complicated. Of course, when we start working on this, it will get a bit more simplified. So we are going to start with the Node.js application. We would set it up on the next video, and set up the sockets IO, and also simulate this multiple instance of a thing. We could use PM to, I think there's an application like that. We could also use Kubernetes. However, we will go ahead and set up our Node.js, set up the Redis. We are going to be using Docker heavily for this, since we're going to be developing locally for now. So most of these things are going to be Docker images. They're going to be containerized, and you can run it locally anywhere in the world. So basically what would happen is, we will set up this application, we would install the socket IO, we would create a sample channel, and also we would create a sample React.js application that would subscribe to that channel, so that we can at least see the communication between these two guys in real time, right? So I think that will be the next thing we will be working on, and that should drop definitely 12 hours from now, at most 24 hours. So yeah.